In this session, we'll be studying the second part of exception handling. So last time we have seen that in order to handle certain test conditions or input conditions based on the user's choice, whatever the user gives as input, that may cause some exceptions at the runtime. To handle that, we have seen the try-catch block and we have seen the standard exceptions. Okay, so just let me know one thing that suppose you didn't know about exception handling, then what logic would you use if you want to avoid the divide by zero error? Without exception handling, what logic would you use? Any idea?
Like I have an idea. I'll declare numerator and denominator, and I'll use if condition that if denominator is equal to zero, then break that is come out of the loop.
Yes, that's correct. Okay, so basically what he wants to say is you keep an infinite loop and you first time you accept the input from the user, suppose, and if he enters the correct input, that is non-zero denominator, then you can break from the loop. But suppose he keeps on entering the denominator or the if you're saying a upon b, then if the value of b or denominator is zero, then the loop will continue. If the loop continues, again you can ask the user to enter the number, and only if it enters a non-zero denominator, then only break from the loop. So this is one common logic wherein you can accept specific inputs, and if it is not satisfied, keep on performing the same action. Once it is satisfied, you can come out of the loop. So you can use this logic in different places, not only for divide by zero. Suppose you want a particular value only within a range 1 to 10. If the user enters 100, then again tell the user to input some value between 1 to 10, and this will keep on going unless he enters a correct value. So this is one logic which you can use to do it. But usually we prefer exception handling because there are different benefits that you get, the error information and all that. Okay, so that is expected exception handling concepts. So we have seen last time syntax errors, logical errors, runtime errors, which are actually called as exceptions. So syntax may be syntax errors, means error in the syntax, wrong, unacceptable syntax. Logical errors, your program is correct, everything is correct, but the logic is wrong. Runtime errors, we have seen the different types. Now there are two types of exceptions. Some are handled by the compiler, some you have to handle, and these are some standard exceptions. Then we have seen try catch block, in which the try will throw the object and catch will catch the object. And we know that we can have multiple try catch, or we can have one try with multiple catch. For example, in the try block, you are writing some code which generates more than one type of exception. So to handle each exception separately, you can have, suppose IO exception, input output, some error is there or something in that, then you can use this catch block. If there is arithmetic exception, means divide by zero error can be handled by this catch block. Or if both of these, IO exception is also not happening and arithmetic exception is also not happening, means these exceptions are not found currently in your try block, and some other exception has been found other than IO and arithmetic. Other than IO exception and arithmetic exception, if some other exception comes out to in existence which you are not aware of, but you still want to handle it, then you can use the general exception. That is the object of the main exception class you can create. Okay, so that, and how it will evaluate whichever exception, if it is matching. For example, if IO exception is happening, then from top to bottom it will analyze that which catch block it has to select. So if it is IO exception, this one will get selected. Now suppose it is arithmetic exception, first of all it will check this catch block. Is it an object of arithmetic exception class? No. Then it will go to the next catch block. Is this catch block having an object of arithmetic exception class? Yes. Then it will select this catch block and no other catch block below it. So whichever catch block is satisfying, it will select that and it will stop. It will not search further. But if it is neither of these two exceptions, then it will keep on searching. And here it is getting satisfied, right? Because this is an exception which takes care of all the types of exceptions. So there it will get satisfied. And after this exception E, after this particular catch block, if you have some other exception, that will not get selected because this catch block can handle all the exceptions. Is it clear? Yes.
Yes.
What
Yes,
about
sir.
others? Yes. Then you can have nested try catch also, in which you can have try catch inside try, or you may have try catch inside catch. For example, you have a try over here. Inside this, you can have another try catch block. And then you can have a catch here. And inside this particular catch, you can have another try catch. So if I use this over here, then let us see how it will work. So you have a try over here. You have try over here. Then you have some lines of code. Then again you have a try block over here. Inside this again you have some lines of code. And immediately after this particular try, you may have a catch. And then this try. Now for this outer try, you need to have another catch. So suppose an exception is happening at this point. Suppose here you're having an exception, which is above this particular try. You can see this try is the inner try. Above this inner try, you have an exception happening over here where the red color is there. So if you are having an exception over here, will this particular inner try catch block get executed or will it not get executed? What is your opinion?
It won't get executed.
Okay, if it is not getting executed, then from this red color line, where is it going, the control?
The exception is being thrown to catch block, the lowermost catch block.
Yes, so you mean to say this catch block. Yeah, so
Yes.
yes, so yeah, so which if it is happening above this inner try, then from here itself it will jump over here and the object will be thrown to this catch block. And suppose here there is no exception at this red color. If there is no exception, but the exception is occurring over here, then this will get thrown to the inner catch only. After this try, you have this catch, so the object will be thrown from here to this catch, and then something all will get executed. So after this catch, you may have some more lines of code inside your try. Means I want to say that here inside the outer try, you may have some more lines. So here you have some lines, then you have try catch, and then you have some lines. Then your outer try is closed, it is over, its scope is over, and then you have another catch for the outer try. So here there is no exception. Then you enter the inside try, the inner try. Here there is an exception. You have caught the exception, you have done the logic, everything. Then if you get an exception over here, that is after the inner try catch block, but within the outer try, means you are still inside the outer try. You are still over here only, inside this outer try. You are here only, but you are out after the inner try catch, means over here somewhere. Here, if an exception occurs, then again the object will be thrown from here to the outer catch. So at different levels, at different positions, you can have the try catch. Similarly, we saw the inner try catch inside the try block, outer try block we have. Inside that we had inner try catch. Similarly, you have a catch block, outer catch block. Inside this outer catch block also you can have try catch. Okay, so this is nesting of try catch block. Is it clear?
Yes,
Yes.
sir.
Yes. Just a minute. Yes, so a quick quiz: write a Java program that allows you to keep accessing an array until a valid index is given by the user. So here that same concept, that if you don't want to use exception handling, what you'll do, you will use a loop, and inside that loop you will accept an index, and if that index is valid you will break from the loop, but if that index is invalid then you will keep on accepting, you'll ask the user to accept again. Now same thing you can have within a while loop, you can have if else to handle this, or inside the while loop you can have try catch also. Okay, inside a loop also you can have try catch. That try catch, you instead of if else you can use try catch over there, means you'll have a particular loop over here. Suppose you have a while loop. Inside this, you will keep accepting. I'll type the program only and show you. So you can have a while loop over here, while true. And while it is true, you can perform the accepting the value of the index from the user. So while true, you can write here that please enter index. You can also specify in the range 1 to 9, suppose. And then you will try. Inside the try block, you will have the statement like, suppose over here I write scanner sc equal to new scanner system.in. Okay, so this is the scanner object. So inside the try block, you will write, suppose the index is what, an integer. So if you store the index in a variable I equal to sobj dot next int. So using this, you are accepting the index from the user. But here, if an exception is occurring, which will be detected inside the try block, it will be detected. Since it is a standard exception, the exception is array index out of bound exception. Then you can have a catch block over here. Inside this catch block, you can write array index out of bound exception and create its object, say obj, or let us say e. And then here you can print. You can say range must be 1 to 10. And this catch block will get executed if there is exception, if it is occurring. So for example, here please enter an index. Suppose I enter the index 11, which is not within 1 to 9. Then 11 will get accepted over here. So I is equal to 11. And then you can also write here, suppose the array is there somewhere on top in your code, then you can write ARR is the name of the array, suppose A of I. Means what you want to do, you want to display the element at the index I, and that which index that is, which the user has entered. Suppose user is entering the index 11, then you are saying that array of 11, that element you want to access. But this line will generate an exception because 11 is not a valid index for this particular array. So here the exception is getting generated. Object will be created in the background. It will be thrown over here. It will be caught over here. And then you can display range should be this thing. So all the statements inside the while loop are executed. But since the condition is still true, again you will go inside the loop and you will say, please enter the index. Then again, it will be checked. If it is again invalid, then you will display that please enter in this range, and then you'll accept the index again. So this will keep on continuing. Did you get it? How we can use this try catch inside a while loop?
Yes, sir.
Yeah. And yeah, so it will, if this exception is not getting generated, means suppose I enter a valid index like 7, then it will print the value of array of 7, means whichever element is at the index 7, that will get displayed. But as you can see, there is no way in which I can come out of this loop. If there is no exception, it will display the element. And after that, what? If there is no exception, only try catch, only the try block will get executed. Catch block will not get executed. So try will get executed. The statements inside the while loop are over. But still it will come over here because condition of while loop is true, and it will say, please enter the index. So what you can do is, over here you can write a break. So if an exception is occurring from this line, line number 41, directly catch block will get executed. If there is no exception, then it will display the element, and then you have break. Break means what? It will come out of the loop. Is this clear how to break from the loop in try catch?
Yes.
Okay. So you can implement this on your own also. Now, let us see some more programs. So here is an example of nested try catch again, in which, yeah, that same program I showed you just now, enter the index. You can accept the index here also. And then you're printing welcome to all. And then you're using another try catch inside the try. And then you're trying to display. And then flag is equal to false, you're saying. And if okay, we'll see what is the meaning of flag. Suppose an exception is occurring, then this catch block will get executed. Suppose exception is not getting if exception is not occurring, then there's no problem over here. So you'll directly come to this catch block also will not get executed because there's no exception at all over here. So this catch is also not executed. So you have come up till here. So there's no problem. Then directly it will print thanks for using this program. But suppose there's an exception over here, then this catch will get executed. And then you will have to again enter the index because it is a while loop. And here we are using flag, and why we are using flag is instead of writing true over here, okay, we can write true over here. And if there is no exception, then you can the break that we write over here as in our previous example, that will work. But just to do it in another way, what they have done in this program is they have used a flag variable. So here you're saying while flag, initially flag is equal to true. So while true, condition is executed. If there is an exception, then from here I will directly jump here. But if there is no exception, this will get printed easily, and then flag will become equal to false. Since flag is equal to false, the loop over here, while false, that is condition is false, so loop will not get executed again. So only if there's no exception, flag will become false and you can come out of the loop. Okay, but if this is you don't want to use so many variables and all, if it is a big program and all that, you can directly go for the previous one where we had while true and break. So that is also possible. Then now we can go for customized exceptions, or you can say user defined exception. Till now what we were doing, already we knew some exceptions like array index out of bound, then we knew arithmetic exception, array store exception, then some string number exception wherein the conversion between string to integer was not valid and all that. But what if there is some exception that you want to specify in your program? So that is you can define the exception class. Till now, which exception classes we have used? We have seen a class called as exception. We have seen a class called as arithmetic exception. We have seen a class called as array index out of bound exception. These classes are already defined with these names. If you want to define your own class called as my exception, suppose, if you want to make this class to perform some operation only if the exception is occurring, means what? Only if the exception is occurring in your program, you want to call some method from this class, right? You want to call some method from this class if an exception is occurring. Then for if you want to define your own exception class, that time you can give the class name as something like my exception, and then it should be a child of your main exception class, that is your general exception class. So all the classes that you want to make as your own exception class should be a child of the already existing exception class. Similarly, this is one class that you have defined, which is a child of exception class. You can have another child also of the exception class. Okay. And then in your program, which is in this class, what you're doing, you're accepting an input from the user, which should be an integer. And if that integer is less than 9, then only the if block will get executed. Okay. So there are two levels over here. One is that you are restricting your input to be only less than 9. If it is less than 9, this code will get executed. But what if the number is greater than 9? there should be an else block, but here there is no else block. Means only the value of a, which is accepted from the user, if it is less than 9, you will execute the if block. And what is inside the if block? Some more restrictions you're applying. What you're applying? The restriction that is nothing but the exception that is going to be defined inside a particular class which you have created on top. Okay. Now here you can see you had created my exception class. So you have created an object, that is the right hand side, as we have seen in our previous lecture. Right hand side is actually the object which you're going to throw using the throw keyword. You're going to throw this and it will be caught over here. Now you can see that you are creating an object of the exception class. Okay, means you're going to refer it using the exception class, and the object creation is by the my exception. Means what? I'll show you over here so that the idea is clear. You have a my exception class which is extends the exception class, and you have defined something, and there is already an exception class which has been defined over here on top, means by the developer. It is available somewhere in the predefined code. Now when I create my object, if I want to create it for the child class, that is my own class which I have defined, I will do something like this, right? Do you agree with me? Yes?
Yes, sir.
Yeah. So this is the object of my own class. Using this object, can I access the methods of exception class? Yes or no?
Yes, sir.
With this, yeah, you're right. And you with this object obj, can I access the methods of my exception class?
Yes.
Yes,
Yes.
sir.
Okay. So this is possible. But let's see who remembers this. I've explained this in the previous session. If I write here exception, now can I access the methods of exception class? See, reference is what? The exception class, and object creation is from my own class. We have seen this concept. Anyone remembers what is the name of this concept? Do you remember dynamic method dispatch? Have you seen this? Okay, anyways, you go through that concept later on. So using this object, we can access all the methods of exception class and the methods which are common between the child and parent. So if inside exception class, I have a method like, anyone knows which method we have? In our previous sessions when we were catching the object, here what we have, exception E. And using that E object, we were saying E dot get message. That means get message is a method inside the exception class. Am I right?
Yes.
Yes. So inside my exception class, I have a method called as get message, and it has some definition. Some code will be written over here. Now, if I have a method called as get message again in my child class, and I have written something, some code I have written. So whenever I call uh, the get message method using this object, I will be able to access this get message method, the child class one, this one get message, not the parent get message, but the child get message, and all the methods of the exception class. So here also we are using inheritance in exception handling. It gives us the ability to perform some operations, and if you want to restrict the scope and all that things. Okay. So here what you're doing is you have an object of that exception class. Using that object, you can call the method get message, or you can simply do println that object as we have seen in our previous lecture. And we know that if we have an reference of the parent class and object creation is from the child class, only the method which is common between both the classes, only the method which is common between both the classes, like get message in this case, will be accessed. And which get message? The child class ka get message. This will get accepted. This will get called. So we have defined something over here. So similarly, inside the child class, which is my exception class, I have defined the get message. And what I'm going to return by this, a string, which is I am get message. Okay, this will get returned. That is why return type is string. So if we don't create this my exception class, and then using the object, we call the get message method, then the get message of the exception class only will get called. If using an object, I say get message, then that get message is the method of the exception class. Do you agree with me?
Yes.
Okay, but now I want the get message to be called of the child class. That is why I'm using this inheritance, so that the methods of the child class and the methods of the parent class, if they are common, then only the version of the child class version of that method gets called, in which I'm going to return a string, I am get message. So here when I say e.getMessage, the child class version of this function definition will get called. And then this print stack trace. Okay, this print stack trace is another method. Can you guess and tell me, seeing the code over here, this print stack trace method is a method of this child class, my exception, or is it a method already existing between the exception class? Yes, print stack trace that I'm calling over here, this method. Is it a method of the child or is it a method of the parent? Parent is what? Exception class. And child is what?
Parent.
My exception. Yes? What did you say?
Parent.
Yes. Are you sure? You're right. Okay. By the you're right. No need to think again. It is a method of the exception class only. Why? Because inside this child class, inside this my exception class, have I defined that method print stack trace? No. So it is a method of the parent class only. Okay. Is it clear? How you can know which method is of which class? Is it clear?
Yes.
Okay. So I have done it over here like that. And then you can have some other methods also inside the catch block. So this is what you have done. Whatever you want to do in the catch block, that you have done it using your own class, which is a child of the exception class. Okay. So the child class can access all the methods of the exception class, which is its parent, as well as it can have its own methods, which you have defined. So inside the catch, I can do as per what I want. So the difference that you can see here, in the standard exceptions like array index out of bound, the arithmetic error, the arithmetic exception, there was no throw keyword. It was optional. But inside your customized exceptions, you have to create the object on your own using this, and then you have to throw it using throw keyword. Is this difference clear? The throw keyword is compulsory for the customized exception, but if it is a standard exception already existing, throw keyword is optional. Is it clear?
Yes,
Yes.
sir.
Yes. Now, what if you want to throw a standard exception? You want to throw an object of a standard exception. So this is also possible. What I'm doing here, arithmetic exception is a class which is already defined. I have created the object. How? Because I can see the right hand side of object creation over here. And I'm passing a message. Now, if this is an object creation, this is the right hand side, right? This is the right hand side of what we write whenever we want to create an object. This becomes the right hand side. And if this is that right hand side and I'm passing something here in the brackets, where this will go, this particular string, this is an exception, to which method of the arithmetic exception class will it get passed? I'm passing a parameter, but to which method will it get passed? Any idea? This is the phase of object creation. And at object creation, I'm passing a parameter. So where will that parameter go? Yes, it will go to the constructor, right? Am I right? At object creation, if you're passing some value within the brackets of the class name, we know that constructor and the constructor and the class have the same name, right? So if I'm saying the class name is arithmetic exception, and to that I'm passing a parameter, means obviously it is to the constructor of arithmetic exception class. Am I right?
Yes.
Okay. Are you convinced what I'm saying? Is it correct?
Yes, sir.
Yes. Okay, so I expected an answer, but anyways. And whatever I'm throwing is an object which will get caught inside E, and I'm going to display it. So when I run this, I have to first of all enter the value of A, and only if A is less than 9, then the whatever is inside the if will get executed. Suppose A is 10, then it will simply not do anything, because whatever logic is there, that is only if A is less than 9. Okay, so I need to run this program again. And I'll print suppose 8. A is 8. Then what is happening? This is an exception, and you're going to throw the object over here, then the get message, and all that will get executed. And get message will be of the child, because whatever get message, we have overridden that method. So the get message of the child, that get message will get called. And also see here that the try block. Inside the try block, at any case, for any situation, we are going to throw the object. That means we are simply throwing the object. But we usually throw the object only if the exception is occurring. So how to prevent this is, you may say that over here, you inside the try block, you can write, if A is equal to 0, then throw the object, right? Because what we are doing till now, if A is less than 9, then in any situation, you have to throw the object. So here you can have another checking condition that if A is less than 9 and if A is equal to 0, then throw the object. Are you getting my point, how it will work?
Yes, sir.
Yeah, so you can throw the object for different conditions. Not necessary if you have come inside the try block, you always have to throw. No. Okay, so that also you can do it. So I hope you have understood this program. Now, there is another thing called as throws. Now, just now what we saw is throw keyword. There is another thing called as throws keyword. The singular is used over here inside the try block, and you have another keyword that is in the plural form, throws. Now, what this throws keyword is done and where you have to use it. This throws keyword, uh, you can use at the method whenever you are creating the method, means this is the header or the signature of the method, and inside the method you will define some logic or some code you will write inside the method. And okay, this is the code inside this method called as area. And this method area, if any exception is occurring inside this method, that time you're going to throw the object. Okay, till now what we were saying, we had some main function over here, and inside that main function we were doing some logic. But your method inside a particular class, inside that method also exception might occur. For example, inside your main method, you may call an object, you may call a method using an object. For example, let me write over here. You have a main method over here, and inside this main method, you don't want to write any logic here, but what you want to do, you want to call a method from a particular class. So suppose this is my class, my exception is the class. Then first of all, I will create an object of this class by writing this code. I'll create an object, and using this object, suppose I have a method called as display. Then I'll write obj.display. Now, what one way is, inside this main method, you will put the try catch block around this object. Try, and here you will have a catch. And here you will catch the object. So what is happening? Whatever code should be there inside this try is nothing but inside the display method of this particular class. Do you agree with me? whatever code should be there inside the try block, that is actually inside a method. And that method is nothing but of the my exception class. So using an object of that class, I'm accessing that method inside my try block. Do you agree with me?
Yes.
Yes.
Okay. So either here you put the try catch, or so if any exception is occurring in this display method, whatever exception will happen, that will happen in the code only, which is inside the display method. That exception will happen there. And if there is an exception happening there, then also the control will jump from here to here. Okay, so if even if exception is happening inside a particular method and you're putting the try catch over here, then the exception is occurring inside this method, so it will come out and execute this catch block. Okay, so this is one way in which the actual code that is generating the exception is in a particular method somewhere, and you're calling that method here. So here actually the exception is happening because this method is getting executed inside the try block. So here the exception is happening indirectly. So it will come to this catch block and it will execute whatever you write inside the catch block. Is it clear?
Yes.
Okay, but there's another way. If you don't want to implement the try catch over here, then simply call the method object over here, call the method display here, obj.display, call it here, and the try catch you will write inside your display method. Inside your display method, there is the actual logic. So there also you can put the try catch. Okay, so not necessary where the logic, where the code is, there only you put the try catch. Like in this case, inside the display method, the code is there. So there I'm putting try catch, not necessary. Where you're calling the method, there also you can put try catch. Okay, so that is one thing that you can do. You can put the try catch over there also. And if you want your class, the method of the class to throw only particular exceptions, means what? You want to handle only particular exceptions, means you want to handle only arithmetic exception, that is for divide by zero. If there is array index out of bound, you don't want to handle it, suppose. Okay, suppose it, this may be the situation. There may be another situation that you have created a class to handle an exception which extends the exception class. This is negative radius exception class which you have defined. So if the radius that you enter, according to this program, if the radius of the circle is negative, then the exception will happen. So what I'm doing, inside my method called as area, I'm going to, means I'm going to call that method over here. That method area has been called over here. And to that method, I'm passing the radius, that is 8 as the radius. So whenever this method is called, the control will jump to wherever that method is defined over here. And that 8 will come inside the variable r. So now r is equal to 8. So if 8 is less than 0, that is 8 less than 0 is false. So no exception. And then you will directly return the result, that is you are calculating the area, so pi r square, and you will return the result if the radius is greater than 0 or equal to 0. But suppose the radius I enter is -2. So r is equal to -2. -2 less than 0, true. If this condition is true, I'm going to throw an object of the class which I defined, negative radius exception, an object of that class I have created, and I'm going to throw. Now you can see here, there is no try catch over here involved. There is only throw. This is also possible. What is happening actually here? This code of checking whether the radius is negative, that means this whole thing which I've highlighted, this whole code should be inside a try block. But inside the try block, what I have a call to that method. I have called that method, and inside that method, a logic is there. So what you can do, either after calling that method, you can throw the object, or inside that method also you can have the throw statement. So what is happening actually? You have try catch over here. Inside this try, you are calling a method, and inside that method, you are going to throw. So only if radius is negative, you'll throw an object. Once you throw an object, you will come back over here, wherever the method was called. So that object which you throw will come over here inside the try block. It will come here. And from here, it will go to the catch block. Because whenever you throw an object, it goes to the catch block. So the throwing is happening from the method. From inside the method, you're going to throw. It will come over here because here you have called that method. And then that thrown object will come over here. and then you can do whatever you want, like get message or whatever. Is it clear?
Yes.
Okay. And then this method was for what? To check whether the radius is negative. You may have another method which defines the logic of dividing. Suppose you want to do a divided by b, then that logic you have written here, like result equal to a upon b, return the result. And you want only the this particular method, if an exception is occurring, then it should throw that exception. So either what you can do, you can write over here, if b is equal to 0, then throw the new arithmetic exception. Okay, you can write like this. So if b is equal to 0, this object will be thrown. But suppose you don't want to write this much over here, what you can do is, to minimize your work, you can write a throws arithmetic exception at the header of the method. At the header over here, you can write throws arithmetic exception. So what will happen inside this method, if the arithmetic exception is occurring, then automatically the object will get created and it will be thrown. Right? Just like how for our standard exceptions, the arithmetic exception error, the array index out of bound, what we are doing, try and catch. We did not write on our own throw over there. We did not write throw over there. It was object creation used to happen in the background and it is to get thrown. Similarly, for this particular method, also here you can write, if this method wants to throw the arithmetic exception, then this arithmetic exception, you can throw it directly without you yourself creating the object. So here you can write throws arithmetic exception. Is it clear?
Yes, sir.
Just a minute. Bunty has come. He's calling you. Bunty. Bunty has come. So I was telling that if you don't want to create the object, so what you can do, throws the class name. So this, what it helps you, that only specific exceptions will be thrown. So if here an array index out of bound exception is happening over here, if there is an array index out of bound exception, that will not be detected and it will not be thrown. So if you write throws over here, only these particular exceptions will be detected and the object will be created in the background on its own and it will be thrown. Suppose you want to handle array index out of bound exception also over here, you can put a comma and write array index out of bound. So these two exceptions only, the object creation will happen in the background if the exception is occurring and it will get thrown. So you can restrict that at the level of the method. You can have the only the throws. Here no need of try catch. If the exception is occurring and if that exception is there in this list that you're specifying over here, if that exception is there in the list, the object will be created and it will be thrown. So there are different ways in which you can do the same thing. The easiest way that we have seen is, in our main method we have the try and catch, we put the logic, everything. But what if the object has a particular method and in that method the exception is handling, that also we have seen. And how to restrict which exceptions we want to throw at the level of the method, only those can be thrown, that is also possible. So is this much clear how to do this in these three ways? Is it clear?
Yes.
What about others?
Yes.
Okay, what about others? Ruchi Patil, Komal.
Yes,
Okay. Yes, okay. Yeah, so this is actually very important. That's why I'm focusing more on this. So, and you might have seen that it is not always compulsory that you have a try catch and inside the try you have a throw. You can have the throw even outside somewhere, as we have seen here. Based on the if condition, we are going to throw. And then that throw indirectly will come inside the try only, right? Because that throwing is happening from the area method. The throwing will happen from the area method and it will come inside the try only. That means you can have throw and the throws keyword outside the try catch block also. Is it clear?
Yes.
Okay. Now next concept is finally block. Now this finally block is used to execute the whatever code you write inside the finally block will get executed even if the exception is occurring or not occurring. Means you are going to have a particular code which you always want to execute. Suppose the exception is occurring, then the try catch will do its work, and after that you want to execute some code. If the exception is not occurring, then the catch will not get executed, only the try will be checked if for the exception. If the try is checked, catch is not checked, then also finally will get executed. That means exception is occurring or not occurring, finally will be executed. But um, you may be wondering what is the use of this, because even using try catch, what happens, why we use try catch? To avoid the abrupt termination of our program. So here you may have a catch block and it will handle whatever if there's an exception, and whatever code you write over here after the catch block, that will always get executed, right? If there is an exception or there is no exception, then also whatever code you write after the catch block gets executed. Am I right?
Yes.
Yes, but there is a special use of this finally that usually that is the reason why people use it is it contains a particular code in which uh, you may want to free some resources or release some resources. You may want to close a connection. Connection means you know that Java programming can be used in the client server applications, web development, wherein you create a network connection, socket programming, wherein you're not only working on your system, but from some other system, from some other machine, from some other server, you want the data. So that time you establish a connection between your machine and the server, and then you get the data from the server. Server is nothing but a remote computer in which may be in some other data center which is not belonging to you, but there's some data is stored which you want to access on your machine. That time you have to create a connection between your machine and the server, that is the other computer. So that time you have to create a connection. So after the work is done, you have to close the connection. So in such cases, you may want to free some resources and all. That particular code you can write inside the finally block. And here another thing that I want to show is if I remove the catch block over here, so there is try block and finally block. Okay. And I'll just comment this out. So here you have A is equal to 7 and B is equal to 0. And here if I do A upon B, so we know that denominator is 0 in this case. So exception should be generated. And here there is no catch block to catch that object which is thrown. Okay. So let us run this particular code and see what happens. So as you can see, there is a try block which will detect the exception and it will throw. But here there is no one to catch because catch block is absent. Okay, so there is something that you've written in your try block that is getting printed here, and then the exception is happening. Here you can have a catch block, okay? Only then it will be handled. Means inside the catch block you can write, please enter valid number or whatever. But suppose there is no catch block, then though this object is thrown, it will not be caught anywhere. Only the detection will happen. But what corrective action should happen, that will not happen. And if the corrective action is not happening, then whatever code is written after the catch block should not get executed. But the finally block is what? Even if the exception is not being handled, then also this finally block gets executed. Okay, so even if the exception handling mechanism is absent, then the exception will not be handled. But still, if it is not handled, program should just stop at that moment, but it will not stop. Whatever is written at the finally, that will also get executed. Suppose I remove this try block and I only have finally, then you'll have an error because finally will always be after a try block. So you can have try catch block and after the catch block you have finally, or you may only have try block and after the try block you have finally. But if you have only finally, that is not allowed. Okay, finally should always be after try catch or after try only. Only finally block is not allowed. Is it clear?
Yes.
Okay,
Yes.
so yeah, so this was another concept. Then this is the last concept for this topic for core Java and for today's session. So please pay attention. As I said, your throw keyword can be inside a if else condition also. And this if else condition is inside this main method. And here you're going to throw something. And if I run this program, I'll first run it and show you. So here you're going to throw, but there's no one to catch it. So in that case also you'll get the direct termination of your program. Nothing else will get executed. Here if I print, I'll print some message like after throwing, I am still executed. Now there is no one to catch the exception. So program will just terminate abruptly. So this particular statement will not be visible when I run this program. Here it is detected, it is thrown, but there's no one to catch. So it is like, it is same like saying that there is no exception handling done over here. But if there is exception handling, then definitely you'll get to see the statement. So that is one thing which you have already seen. Now if 4 is greater than 1, that is true, then you are going to throw. Now you may have another class which is your own class which you have defined, and inside this class you have a constructor in which you're going to you're going to store a string value in exp class, and then you're going to display that string. And here if you are using if else with the throw keyword, if else has been used and inside that throw keyword is there, but there is no try catch. Okay, so here also you cannot use the finally. So finally, even if throw keyword is there, you cannot use finally. You can use finally only if there is single try or if there is try catch and then finally. So using if else, you can throw, but no one will be there to catch it. So you should usually prefer to go with try catch along with if else. You can use try catch and if else both, but you can use try catch alone also, but you cannot use only if else for throwing. Is it clear?
Here can we use a catch block after the if else?
Okay, we can try that if you want. So here I'll just come uncomment some things. Here I will comment it. So I have a class in which I have a main method. And here we are going to throw an exception. We need this class called as my exception. So this is needed. Okay, so this what will happen if 4 is greater than 1 true, you're going to create the object because it is your own class. You're going to pass this string. This string will go to the constructor and it will get stored in exp data member. And then using inform method, you can display that string. Now you have an else also which will not get executed because 4 greater than 1 is true, only if will get executed. Now you may want a catch block. Usually catch will come only after a try, but still let us try if catch is working. I don't think it works. So as you can see already it's showing an error that catch without try, as you can see. So try, after that you can have catch, and after try you can have finally. But catch and finally cannot exist on their own because try is the main block which will detect the exception. Without detection, you cannot throw any object, you cannot catch any object. Okay, so is your doubt clear?
Yes.
Okay, so these were some cases of try catch, okay, to make your software more reliable. That was our main aim. Okay, so a quick revision of all the object oriented concepts which you have seen till today. We had started I'll just show you when we had started, what concepts we have covered. I'll just give a summary. So even the procedural part, that is, we have seen what are variables, operators, then if else, for, while, do while. Then we have seen arrays, strings, then the special classes, string builder, string buffer, to create the mutable strings. After that, which was very important, is object oriented programming. First, we understood what is class, how to create object of the class. Then what are static members, what are normal methods. Then we have seen public, private, protected. We have seen the concepts like encapsulation, abstraction, polymorphism, inheritance. Then we have seen in detail all those four concepts. We saw encapsulation when we were creating classes and objects. We have seen abstraction when we use the public, private, protected keywords. Then we have seen the uh, inheritance concepts, dynamic method dispatch, and how we have two different types of inheritance. Then in inheritance itself, we found a problem in multiple inheritance. We solved it using interfaces. Then polymorphism, which was nothing but inheritance only, just that it was the runtime polymorphism method overriding. We have seen multi-threading, very important if you want to improve the performance of your system. And then finally, exception handling to get the reliable software. And then these are the assignments also which are provided. Hopefully you have attempted them. So from next session, that is not on Friday, today is Wednesday, Friday 26th we won't have session. Next session will be only on the 3rd of December, because on 3rd of December you're going to have your end term exams will get over, right? If you have got this timetable which I'm showing you right now, we know that even I and even you have exams the next week. So our exams are getting over on 3rd. So that day we will be free. So at 5 p.m. that time we'll have our class, and that time we'll start off with advanced Java. So till then you also have time to practice all these concepts. Videos are available, study material also, remaining ones I'll upload. Assignments are also there for your practice. And whatever extra you want to do, you have to upload your self practice programs. Okay, so you have almost a week to practice all this. If you are lagging behind or if you have missed some lectures, you can cover up. And then directly we'll start with advanced Java. We'll start off with the concept of servlets. Servlets is used in the web development phase. So we'll directly start off with Java used for web development. So it will be quite interesting. But before that, you need to know object-oriented programming in Java. Otherwise, you'll get confused over there. So is it clear? Any doubts you have, you can ask me. And if no doubts, you can put your attendance and leave the meeting. Thank you. So we actually took 21 days, because in between I had taken one half an hour class and all. We missed out on some sessions and all. So within 21 days, actually it is 21 hours, because 1 hour per day, 21 days means 21 hours. We have finished core Java, procedural as well as object oriented. Any doubts?
No, sir. Thank you.
Okay, welcome,
Thank you, sir.
welcome,
Thank you.
welcome,
Thank you, sir.
Thank
welcome,
you.
welcome,
Thank you, sir.
welcome.